Welcome back to Miss Eddie's Math Movies, where it's cute to be a square. Today's lesson is 5.2, all about side, 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 and side angle side. By the end of the lesson, you will be able to show triangles are congruent using SSS and SAS. To show triangles are congruent, we are going to write some proofs. And a proof, it's definitely what it sounds like, it's a convincing argument. It's like having proof. That shows why a statement is true. So we're going to show why triangles are congruent. We're going to prove it. We're going to have convincing arguments why a statement is true. So previously, when we were looking for two triangles that are the same, we had to check all three sides and all three angles. Well, that's a lot of work. So we have a shortcut. And our first shortcut is, instead of looking at all three sides and all three angles, we just have to look at three sides. This is called SSS. If three sides of one triangle are congruent to three sides of another, then the two triangles are congruent. So notice here's one side that's congruent, here's another side, and here's a third side. Since all three sides are equal, that makes these triangles congruent, and we're going to write a congruent statement. MNPQRS. So it's our shortcut. SSS is our first shortcut to proving triangles are congruent. So this is asking us, can we use SSS here? Are these two triangles congruent? Well, here's one side the same. Here's another side the same. So I've got SS in each triangle. Then if you look, they're sharing a side. So JK is equal in this triangle, it's equal to JK in this triangle. So they're sharing a third side, so I'm going to put an S there. Now if you look at each triangle separately, this triangle has SSS, and this triangle has SSS. That means we've used it correctly because it's in both triangles. So we had once HJ was equal to LJ, HK was equal to LK. Then when they're sharing JK equals JK, do you remember that's the reflexive property? So whenever they're sharing, that's going to be reflexive. So we just used SSS to prove the triangles are congruent. HJK is congruent to triangle LJK. So that's our first shortcut we're going to use. Our second shortcut is side, angle, side. So this is our second shortcut. So now we've got two sides and an angle. What's really important is the angle is included. So circle or star or highlight that. We need the included angle. Then the triangles are congruent. All right, so we've got a side, oh, and another side, and then look, this angle is right in between. Right in between. So side, angle, side, and then PQR is congruent to WXY. So I need you to make sure you understand the difference between having an included angle and a non-included angle. So let's draw a picture over here. Draw two different triangles. And here's side, angle, side. And here, all right, so this is side, angle, side. And this is good because the A is right in between the two S's. Here, the A is not in between. This is angle, side, side. This is not good. So to help you remember, I came up with a little saying. The saying is, you can have SAS, but you can't be an ass. This is good. When the angle is in between, that's a shortcut we can use. But when the angle's not in between, it doesn't work. It's not a shortcut. So let's see if we can see if this is side, angle, side. So look, I see a side that's the same. Oh, and I see an angle that's the same. Do I see anything else? Do you see anything that they're sharing? Well, they're sharing BD. So I can put a side here. They're sharing that side. So let's look at each triangle separately. Side, angle, side. Side, angle, side. And you see how that angle is in between the S's. So yes, this is SAS. AB is equal to CB. DB is equal to DB. So there's my two sides. And so there's my two sides. I need to talk about my angle. And let's see, it says AB and DB. The included angle is ABD. And the included angle here is angle CBD. Let's look over here. Here's a side. And here's an angle. And then I see they're sharing a side. So I'm going to put an S in the middle because they're sharing. Anytime they're sharing, that counts. So let's look at it. I've got an angle and a side in both triangles. Is this side, angle, side? Well, right, if I color in, here's the side, here's the side. Is the angle in between? Is it sandwiched right in between? No. No, it's not. This is angle, side, side, which doesn't work. So this is no. The angle is not in between. And for SAS, the angle has to be in between. So we use SAS on the first one. But on the second one, you cannot use side, angle, side because the angle is not in between. We had a side and we had another side, but these angles just weren't where we wanted them to be. So where did we want the angles to be? We want the angles to be here and here. That's side, angle, side. Side, angle, side. So we want angle HGE to be congruent to angle FGE. Those would be the ones that are in between, but that's not what we had, so it did not work. So you're going to do this checkpoint now, and it's either SSS, SAS, or no. Those are your possible choices. So when we write a proof, or basically we're going to do this, but we're going to list out all our information. You list the given information first and decide whether you can use that information or if we need to keep going. You're going to put your statements in order and you have to give a reason, right? If we're going to write a proof, if we're going to write a convincing argument, we have to have reasons. And you always end with what you're trying to prove. So let's see how this works. We need to prove that these two triangles are equal, are congruent. Well, here's a side. Here's a side. So each triangle has two S's so far, two S's in each one. And oh, they're sharing a side. So what am I going to use here? I'm going to use side, side, side. Because look, each triangle, SSS, SSS, has to be in both. So now I need to list each side. So one side, see we have it listed, HJ is equal to LK. That was given, right? They put that on the picture for us. That was given. HK is equal to LJ. That was also given. Then they were sharing. Anytime they're sharing, you use the reflexive property. We should write ourselves a note there. Sharing is the reflexive property. they're sharing JK. JK in this triangle is equal to KJ in the other triangle. You can write the letters the same way or flip them, it doesn't matter. But if I look here, I see JK and then KJ, so that's why I flipped it. Doesn't really matter though. And so what did we use? We used SSS. And that's why I talked about all three sides. That's why I have a convincing argument, because I talked about three sides and I used SSS. So now I have to prove that this triangle is equal to this triangle. Well, let's mark our picture. DR is perpendicular to AG. If you remember, perpendicular means right, it forms a right angle. So I'm going to put a right angle in here. May as well put one over here. And RA, let's put a tick mark on RA, is congruent to RG. I have to prove that these two are the same. Okay, well, I see a side that's the same. And I see an angle that's the same. What else? Oh, they're sharing a side. So what am I going to use in each triangle? Side, angle, side. Side, angle, side. So I know at the very end, I'm going to be using side, angle, side. Well, now I got to write down all the things that I found. I got to write down my side that I found, my angle that I found, and my side that I found. So here's one side, already written down for me, RA, and that's because it was given, right? They told me that right here. That was given. Right, our givens are just the things they told us. So they told us that, and they told us this. And then this is what we're trying to prove. Well, okay, we need to talk about these angles here. And this was a clue to help us. The clue told us we had right angles because perpendicular lines form four right angles. And if they're right angles, then they have to be congruent to each other. All right angles are congruent. So here's my angle I talked about. Here's my side that I talked about. Here's my angle that I talk about. Now I need to talk about this, what they're sharing. Remember, when they're sharing, it's always reflexive. They're sharing RD. So RD in one triangle is equal to RD in the other triangle. There's my side. So I talked about a side, an angle, and a side. And that's good because I used SAS. And the last line is always what you're trying to prove. I'm trying to prove DRA is congruent to DRG. All right, now you get to try one on your own. So decide, are we going to be using side, angle, side, or SSS? Okay, find your givens, write your givens in. Then it says angle BCA. Why is this angle equal to this angle? You're going to write that reason right there. What kind of angles are they? So you're going to finish this now. This is M Cubed signing out.